Mr. Joe Sack. Hello again.
Hey, Kimberly.
I am I am loving chatting with you and I'm so happy to be doing this. It's amazing. And this whole vector thing. I really want to start with what the heck is it? Like when I heard vector, I thought, is that are they using that for an index name? Is it a data type? Is it like just in general, tell me what this means.
Yeah, so let's start with, by the way, I'm going to give you the layman's description. So if there's a data scientist looking and going, well, actually, it's
Yeah.
just no, I know I'm getting a little loose, but one thing to note, what is a vector? What will you see as a SQL Server professional?
Yeah.
It's like a list of numbers. Let's just start
Okay.
there. So like it's a list of numbers that has a meaning,
Okay.
that it has semantic meaning. And I'll give you a concrete example, but when you hear vector or you hear embedding or vector embedding, it's the same thing. Like I have
Okay.
this model that was trained on billions of lines of text, and it learned patterns from ingesting that text, and it outputs the text that you provide it with this string of numbers. And those string of numbers, the numbers that you have are dimensions, and that number has meaning,
Okay.
and you can then store it in a database. Doesn't have to be SQL Server, it could be someplace else. That number then is a math operation later on. So if I have a question and I go, show me all properties that have a nice vibe about them and are by a park or are nature friendly, I can send that query in. That query gets its own vector embedding, so it becomes its own set of numbers, maybe 1,500 numbers. And
Okay.
then we take this 1,500 numbers, we compare it against all the rows in the database and go, okay, math, cosine distance, how much does the angle differ between
Wow.
all these numbers and this number? Show me the distance that is the smallest, and then that tells us the the semantic distance or how similar my query is to document A, B, C, D, E. And this,
It
by
re
the way, brushes a bunch of different concepts, but that's just a start.
it kind of I mean it kind of reminds me of the nearest neighbor concept. Like how would
Yeah.
you okay.
Yeah,
I'm
it is
just
the nearest neighbor. So you have, and so in this case, like SQL Server offers, and by the way, in the industry offers like exact nearest neighbor. So we are brute force. Then the example
okay.
I just gave you was a brute force. Like I'm going to take my query, and for each document in each row in my table, I'm going to compare embeddings, look at the distance using cosine. You have dot product, you have Euclidean. Most often, you're going to use cosine.
Okay.
Compare, and then show me the top n, so top
Okay.
10 that compare. That's exact because it's brute force. And then there's approximate nearest neighbor capabilities,
Okay.
which come through a vector index, which we can talk about.
Okay. Yeah, I mean I think back to I mean this is quite a few years ago, but I worked in a law library and we had LexisNexis Westlaw. And, you would want to search on cases that were similar to the one. I mean, I wasn't in law school. Actually, Kira's in law school, our youngest
Ah,
daughter, which is very exciting. But I just remember I was working in the law library more as a computer geek than anything. And people would say, oh, I want to find God, I don't know why this came up. I think I've been watching too much true crime, but like murder with knife and you'd want to find those words within a certain number of words of each other to
yeah.
understand that there was a correlation
Yeah, there
between
was like a
those words.
distance, and and by the way, and so it gets kind of into the full text search where you're like, okay, show me distance. In this case, these embedding models that people are using today, and they could be open source, they could be closed source. These models that are being used to create these embeddings, these
Okay.
vector embeddings, will then allow you to go murder. There's so many different words for murder. So like
Right.
um, passed
Homicide.
away not by
Yeah.
choice, or so it will be
Wow,
able to
passed
find.
away not by choice seems a little broad, but
It's
okay.
more Midwest, but you'd be
Really
surprised
polite.
there's an there are things that it will match on. Like I don't know if you ever saw the SNL. There was a skit about silver Amazon, um, where it was a silver Alexa. And I find that I have this as I get older. Like I don't have the right search phrase, so I'll be like, that one actor who's kind of tall, was in those movies about the blah blah blah, and everybody's like, I don't know what you're talking about. oftentimes vector search does. So like we're
Wow.
perfect partners here. I'm talking to Claude Code like, yeah, I put that somewhere over here. Do you know where I found it? So it allows
Wow.
you to do really fuzzy search,
Okay.
semantic equivalence without getting it exactly right because it creates um, I mentioned the angles, like you could do cosine similarity. So think of I want to compare the angle of these texts to say how similar are these. But you can also do things like magnitude or distance
So,
without having the exact terminology. Which full text search you could kind of do this with synonyms. You could do it with like you were mentioning, like the number of words off from the distance. Like there's all kinds of ways you could do it, but there's still a lot of tuning that you have to do versus like this multi-billion parameter embedding model that's already been pre-trained to do it. You send it to the model, spits out the vector, put it in the database, compare.
okay, so if I think traditionally of databases and my role in databases for years, I would look at individual columns and I would be indexing them for generally equality predicates and, depending on what data type it was. But my point is, am I am I using vector on any individual? No, any individual columns, right? It's all on documents or descriptions, like a property
I see what
description,
you
or
see. Yeah,
like
yeah.
where do these get used, and how would a DBA say, okay, now I understand where I would put that?
Great question. So I mean, a lot of the cases you probably see first in SQL Server will be text based, but you
Okay.
can also create vector embeddings based on images or audio. If you
Images.
yeah, so
Wow.
images. I have so okay. Let me tell you something I did on SQL Server
Yeah.
2025.
Okay.
I have 24,000 photos, which for you is like nothing. I'm sure that's like your Thursday afternoon. You're like, "Bup, bup, 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 bup,
It
oh,
is
20,000."
sometimes.
Yeah,
It is.
yeah. So, but imagine people like me. It's like that took 11 years to get 20,000 photos. And I'm doing these Substack posts. And sometimes I want to pull a real photo. Sometimes I want to do something that's like generated through Nano Banana. And I want to search through it through kind of abstract terminology. So I used an embedding model to create vector embeddings of all my photos, and then
Wow.
I store them in SQL Server. And then I can do things like show me an angry squirrel or a very fat chipmunk, or show me a
And
red
you have
dress,
fat
or
chipmunks,
I have
Joe.
very fat. I overfeed them. It's kind of
I
abusive.
know. That's
Yeah. So it allows me to find it in a way, and you'll see this on like the iPhone, like you can like, or if you're on Android, like
Oh,
you
I
can do
love
these
that
photo
feature
searches.
actually. Yeah.
Yeah, but this actually is even you can make even better search. So that's an example where the vector embedding model created an embedding based on the image. And these things are really, really good. And they also even find things because remember, it's based on their training data. So, like, I was into old masterpiece theater. Like, there's a show called I Claudius. I'm sure I talked to you about, and it found pictures from I Claudius that I had taken these kind of like Warhol-esque images based on it. So
Wow.
that's the kind of capability that you now have. This was on a local SQL Server 2025 instance. And I created the front end through Claude Code. I type in my search phrase, it finds my images. And
Wow.
so you
Okay.
have that. Most often, people are going to probably be doing text based. In terms of what kind of data, think of it wherever you want that fuzzy or contextual semantic type search. So that could be pretty
Short
short columns.
descriptions,
It
long
could be job
descriptions.
descriptions. It could be titles. It could be, it's unlikely to be
Oh,
quantitative data.
titles. Yeah.
Yeah. You name it. It could be done because how many ways do people put in your
Right.
address, or how many ways do people put in location based where they've misspelled it somewhat? It's not that's not the most interesting scenario, but it's definitely
Right.
one that
Right.
could be helped with.
Wow. Okay. And I was just even thinking of names and misspellings and things like that, or short names, or like Kimberly gets spelled wrong all the time, and then
Absolutely.
Kim, Kimmy, although people are killed if they call me Kimmy. But you know what I could see where if there were notes or things that you were searching through, like find me all the references to Kimberly Tripp, yet people sometimes refer to me as Kim Tripp, or is that, I mean, is
Yeah,
that
it,
something? Okay.
it can help with it. You want to think about it from a training data perspective.
Okay.
So think of like, would that have been in like if I think was there SQL skills blog posts in the training data? Very likely. Okay. And very likely situations where Stack Overflow had links to your content and had your name
Wow.
associated with it. That was probably part of the training. And a lot of these
So
trainings are distilled, compressed versions of the internet, right?
right, so that's
So
super interesting in and of itself. So all of this training data is basically the knowledge of the internet distilled down into what it understands that information to mean, and
exactly. It's like a
then
think of a compressed, lossy representation of knowledge.
wow.
And that's also why we need RAG, so retrieval augmented generation, because that training probably stopped as of 9 months ago or a year ago, and so
Right.
it's not going to know about the Substack post or the SQL Skills post that just happened today,
So
and
when is
so
it going to
hence
get updated?
well, that's the thing. So they'll do training runs, and so you get these. So you go onto Hugging Face, and you can track the different embedding models, download the latest ones. But there's almost always going to be a few months latency, depending on the model that you're talking about. And no matter what, if your application is depending on the latest and greatest data, you're always going to have that RAG component pulling that
Okay.
into the context. So if I say, "Hey, show me the most recent blog post from Kimberly," if the training showed your last post from 2 years ago, then you're probably okay. But keep in mind, again, this is compressed knowledge. So it
Right.
might know, yeah, there was a post, but it got bits and pieces of the what you actually wrote about, versus you
Right.
may still need to pull in that content in its holistic form if that's critical to your particular search. Like if you wanted to
Interesting.
pull out a table or something specific that you referenced. So RAG is always going to be part of the conversation here. It's never going to be the model's always completely up to date. It's cost
Right.
prohibitive and it takes forever to train them and it's expensive.
So how do you get that model into SQL Server? Does SQL Server come with a model or talk to a model externally such that if that model gets updated, it gets updated? Like how does that
We'll
work?
have so by the way, I'm resisting the temptation to because even then I've kind of brought in we've been talking about vector embedding models. Now we're kind of talking about LLMs
Okay.
because when I was talking
Okay.
about RAG, it was really like LLMs. There are ways to do LLM calls from SQL Server.
Okay.
I'm more philosophical about those, by the way.
Okay.
I don't necessarily love that as much as I love the embedding stuff. I'm
Okay.
bought in on vector search.
Okay.
When it
And
comes to when we start interacting with the LLM, I'm not so sure I want that in the engine. We
okay.
that's its own 15 minute for sure. We got to
Okay.
talk about that one.
So just for right now, it's pretty intelligent as far as understanding a lot of phrases and likenesses and
Yeah.
similarities and words that you might use that mean the same thing and bringing them all together. And we don't need that to get updated every 6 months. Like it would only be,
No.
if somebody was looking for a specific news article, and we wouldn't necessarily be storing that in SQL and then searching on that. I mean, that's other environments do that kind of thing. So what we're really talking about in SQL is taking the data that you have and
Yeah.
then taking those descriptions and taking those things and then being able to search a lot more fuzzy for them and a lot more with like natural language. I mean, we've talked about
Yeah, and
natural
we've
language options for a long time, but we've never had any great ones.
yeah,
So,
and I think I remember English query and
yeah,
I
I
mean like
know.
there's
That's
a big history. By the way, so many things where I'm like I wish I had this 20
20
years ago.
years ago. Yeah,
Um
exactly.
but to your point, by the way, there's the line of like, okay, we talked about a vector is generated from this embedding model
Yeah.
that reads a bunch of text and learns patterns, and then you can send your text to it. It spits out, like 1,500 numbers. You store those numbers. You can do mathematical comparisons. Then there's the whole discussion of like large language models, small language models. Those are much bigger, lots more parameters.
Right.
Those are the
Okay.
things that I'm saying we need to provide it with context. If you want up to date news
Right. I got you. I
as
got you.
part of your prompt and conversation, we need to provide it.
Which is
But
very
there is,
different than, yeah.
it's different, but it's also, I'm glad you brought it up because SQL Server, there is like a method for you to interact and chat back
Wow.
and forth. But I'm more dubious on that than I am about the need to store vector embeddings and to have the capability to search it. And
Yeah.
and I think
And I
it's
think
more
that's what
like
people need. They
they
need that
they
ability.
definitely need that. That's
Yeah.
kind of that's the table stakes. But then when we get into the actual, I want chat in my engine. then we're talking like,
That's
remember
different.
R
Okay.
integration
Yeah.
and Python integration? It's like, okay, well, where does this really belong?
Yeah. No,
Um,
that makes sense. Yeah, and I didn't really mean that specifically. I just meant
uh,
whether or not it would fully understand. But I see that you're building your index from your data, which is generating all of the different words and value. I don't want to say pairs. It's just, I think of that because a lot of us historically would take large amounts of data and try to find keywords and pull them into columns so that we could then
yeah,
search on them, right? Like so that we didn't have to do the XML indexes, which were sometimes very bloated, and at least especially in their first release they did get better, but this is so much more, so many more capabilities, and that ability to understand the relationships between the words, not just the existence of a word,
yeah.
is so powerful. So it's really fascinating, and I'm just learning too. Like this is so new to me, and
I think
it's
everyone
yeah,
is, and by the way, I don't want anybody to walk away from this thinking this replaces everything now. Like, oh, we're
no,
good,
no, of course not.
because it's we will need hybrid search. That will actually be the default. Like, we're going to need predicates that say where company ID equals X, where salary greater than that, where listing price less than that. We're going to still need well, I mean, full text search has kind of been on the wane for a while, but like
Yeah,
that kind of capability, there's
yeah,
still a place for that. Like, that's not over, but I would just say hybrid is going to be the norm because even think like, I'll give a classic example. Semantic search and vector search is very bad with negations, where you say where something not that.
right,
It's like, well, you said not kitty. Here's a picture of a kitty. Because it's just shares the same. You talk about a cat. Here's a cat. And so you see where it's that imprecision. You're like, no, I said not kitty. Now, whether it gets better at that, who knows? But in the meantime, you're
yeah,
going to need to decorate your where clause still. You're still going to need to join to other tables. You're still going to need to normalize in the way you've been normalizing. It's just that you now have this new composable activity to go when people come at you with something vague and amorphous or something where there could be 50,000 ways it could be expressed. You're
right.
now having a better way to recall the right data compared to having a bunch of hard coded functions or lookups or heuristics.
Would you almost say, I always think in terms of how this is going to be presented to the user as well. Would you almost say that if somebody had a dialogue, they could have at the top part of that dialogue or that web page or whatever, do you know the customer's customer ID? Do you know the customer's last name? Do you know exactly what city they're in, or anything that might be an exact match? And then,
Yeah.
if you don't, then maybe what are some of the things you would search for? I mean, would you still say that people want to almost offer their users a series of options so that they're not necessarily just going to the fuzzy match initially?
Yeah, yeah. So a couple of trends. I'll pick one of them. If you think of Claude Code, so Claude
Okay.
Code's command line, you connect with Anthropic's models. It's amazing. There's other examples like Codex, and Google has a command line as well. And one thing that I'll notice it will do, if you give it a problem space, it will come back and ask sometimes, not all the time, not as much as I would like actually. It will
Okay.
come back and ask a few clarifying questions. And it even has improved the interface. Will go, which would you like? Option one, option two, option three, and if you want option three, blah blah. So it'll do follow-up questions.
Okay.
So I think the world is owned now by as lazy as possible is what we need to design it. And then I mean, I'm like 100%. I'm like, you'll figure it out. And then I
Yeah,
get
yeah.
mad when I wasn't specific enough,
Yeah.
and it went off and wrote the world, and I'm like, no, no, no. And
Yeah.
but it's getting better. Like Claude Code, I've noticed this will get better at knowing when to ask you a few clarifying questions. And you can usually have in the system prompt things like always ask clarifying questions. So you could tell
Okay.
it by default, ask them. So when you talk about that interface, I think it's more likely that when you have a salesperson who's like, I need to know everything about this customer and what properties they own and what their transaction history was, and then any support case that they opened up,
Yeah.
they're going to want to just say that.
Wow.
And then if that specific information is not there, I think that the model, I think the LLM call should come back and go, that's great. Do you happen to have, I don't mean to inconvenience you, but do you happen to have, because I see there's 15 companies that sound like that. Do you happen to have the
Wow.
ID? Or do you happen to know the range because I see that they've been your customer for 42 years? You want to know the last 6 months? So asking the clarifying questions like you would with a
Wow.
human.
Yeah, I it that just goes so much against like me from, you know what I mean, as a database person. Like I
Yeah.
always, again, I'm kind of back to the help me help you, and I think of how do I help the database's performance, and part of me, forgive me, thinks in terms of traditional indexes and equality based searches and lookups, and I feel like that would be faster even though it's not easier. Are we at a point, you think, where the easy searches are fast enough that we can go that route without trying to force the equality based matches? I mean, that's kind of amazing to me if that's the
Yeah, I
case.
think it's by the way, I don't think that this sidesteps any of the needs that we have for the proper indexing, proper normalization.
Okay.
We are just talking about the front end, like what users are going to expect. Like
Right.
the
Okay.
what's the expression? Don't make me think. Like don't make me think. Like just let me, and then it'll come back. But that doesn't mean that we can't intelligently design the database, the data tier, the stack, and then also come back with follow-up questions. And
Right.
I saw this a little bit when I was back at Microsoft for the third tour of duty. It was around the natural language to SQL capabilities and about the DBA side bar, like, hey, take a look at the database. There were things where you had to really gate what the LLM could do and really, but you gave it a little bit of free will to go, okay, I'm going to construct this SQL statement, but there were best practices that you wanted
Yeah.
to work from. So I think it doesn't magically make anything faster. If you're just looking for semantic search, yeah, the KNN approximate KNN can be very, very fast. But I think in the real world, you're always going to need that hybrid piece. You're always
Yeah.
going to need to, it's just for this tenant or it's just for XYZ. So we're going to have to build that in, but the
Yeah.
LLM is going to have to be aware of it.
Yeah. Interesting. No, it's definitely fascinating. Like I've been looking at it and figuring out exactly where I could use it. And for me, I see a lot of uses, but I don't see any of my old tips and tricks going away.
No.
I just see multiple ways now of finding things that I could never find before. I mean, that's huge. Like just being able to go through images and documents intelligently by color, by, find all the images that have a rabbit or,
Yeah.
a bird, or, and then even, what kind of bird. In my images, there's a lot of birds, right? And
I have a killer use case for you, by the way, that just happened. We had a tree fall on our house over Thanksgiving, and it
I'm
was a dead
sorry.
tree. We
I
had a
didn't,
dead tree,
I did
and
not know that,
and the
Joe.
tree's been dead for a long time. And we've like been doing our Midwest, like, hey, like it's dead. Like here's a tree cutter, and like thanks, and then they don't do anything. Anyway, so I used that photo app to go show me dead trees, and it found a picture of that tree from 2015, and its bark was falling off. So that's the example of kind of
Wow.
the power there. Like, do you think
Yeah.
how else would you have done that? Like,
Yeah,
yes, I
yeah,
could have gone through the 20,000. I could have definitely done a search, like a naive search on trees, but I was looking for dead trees.
yeah, yeah, yeah. No,
Um, so it,
and that's
yeah,
definitely a different criteria. And I'm
yeah,
sure live tree, the number of photos you would have had to look through would have been huge, or just tree. So,
yeah.
no,
And
that's
one more
cool.
for you, by the way, on this subject. Like,
Yeah,
when do the photos contradict what your relational data is telling you? So, like, I did a Substack post on this where I had property inspection reports that said no water intrusion, everything good, and then there was a photo with like water pouring on
floods.
the ground,
Yeah.
and then I said, show me all records. And again, part of this is classic relationals, some of because you're going against classic columns, where I'm looking at the description but then show me the compared to the vector embedding on the photos and show
Wow.
me what's inconsistent. So you're also unlocking ability to do contradiction or anomaly detection
That's cool. I mean,
using these
that's
embeddings.
unbelievably cool. So it's definitely taking us somewhere that we've just never had that ability to go with even the data that we might already have in SQL
Yeah.
Server. Um, that's interesting because in a lot of cases, I would recommend that people store their images as just like if it's a JPEG outside of SQL Server. Are we now required to bring all of that into SQL? Oh,
No, you still
interesting.
stick with that. Yeah, you still stick with that. But the key is, and this particular post was something called like a call poly, which is basically it's like micro embeddings. Like it's
Okay.
basically it does like a grid across your photo, and each section or patch of the photo gets its own embedding. So you get hyper accurate because it can pull out things like charts and graphs and really
Wow.
get the intent versus like an OCR equivalent.
Yeah.
And by the way, storage, hello, you could like it like because now all of a sudden one document has
Yeah.
X number of vector embeddings, but you get very, very sophisticated embeddings. But the whole
Is
thing
there
is
an
that doesn't mean. Oh
sorry.
yeah.
No,
Oh no
just
no. It doesn't mean that the photo gets stored in the database though. It means the embedding gets
right.
stored in
Okay.
the database, and you can still have a pointer.
That's awesome. Okay. And just I'm thinking of XML and how much larger the XML indexes are relative to the base data. Is there a number that we use or can you choose that? I guess I
Yeah.
guess you could choose by data type, but tell
Let's add that to the list of
okay.
things to talk about because to talk about that we'll want to talk about dimensions, the
Right.
number of dimensions that you have, the vector data. But the answer is like the TLDR is you need some disk space. Like there's
Okay.
like these things are chunky and you need to factor it in and it gets big quickly.
Yeah, I can't wait for our next one because I want
Yeah.
to talk about do you put them in the same database? Can you put them in a different
The
database? Do
same
you
table? Do you do
store
it a
them as
separate
columns?
table?
Yeah,
How do you do
okay.
version control? How do you do swap out? Yeah, there's
Oh,
a bunch of stuff. Yeah.
okay. Yeah, and I guess, yeah, okay. I'm going to leave it at that. But this is very cool stuff, Joe. I'm looking forward to
Thank you,
our next
Kimberly.
discussion.
Fun
Thank you,
chat. Thank
everyone.
you. Bye bye, everyone.
Bye.